Most people find it hard to believe, but in the late 19th and early 20th centuries, ships made of concrete were not only real, they were actively built and used. At first glance, the concept sounds contradictory. How can a ship made of something as heavy and rigid as concrete float? The answer lies in basic physics. The principle of buoyancy, first formalized by the Greek mathematician Archimedes, applies regardless of the material. A floating object displaces a volume of water equal to its own weight. As long as the total density of the structure, including internal airspace, is less than the density of water, the vessel floats. In fact, many modern steel ships are denser than water, but they float for the same reason. Concrete ships benefit from the same principle. Despite their heavy construction, they can carry large loads and remain stable on the water. Their mass even makes them less prone to capsizing in rough seas, though they typically move slower due to their weight. The first concrete boat on record was created in the mid-19th century by an innovative European inventor who used a metal framework coated with cement. By carefully distributing reinforcement through the hull, he was able to construct a strong, crack-resistant vessel. His design, showcased at a major European exhibition, generated international curiosity. At least 3 boats were built based on his patent, one of which remained in service for nearly 50 years. During a major global conflict in the early 20th century, a North American government initiated a program to construct large numbers of concrete cargo vessels. Steel shortages at the time forced engineers to explore alternative materials. Though only a dozen of these ships were completed before the war ended, the experiment cost tens of millions in today's currency. These early concrete ships were mostly used as tankers for transporting oil and dry goods, ideal because they were immune to the corrosion problems plaguing steel hulls. The largest of these ships reached lengths of over 130 meters and weighed more than 4,000 tons. However, they had a relatively short average lifespan of about 10 years. In collisions, their rigid structure often led to catastrophic failure. In one tragic incident, a cargo ship sank just minutes after a collision, taking nearly 20 lives with it. Despite the risks, concrete shipbuilding spread across several countries during periods of material scarcity. Over 1,000 concrete vessels were built globally, with a combined tonnage of more than 600,000. These included everything from barges and ferries to ocean-going ships. Another boom occurred during the second major global war of the 20th century, when both European and American shipyards built reinforced concrete vessels. Some were even involved in atomic bomb testing to study structural durability. In the decades that followed, concrete construction proved invaluable for stationary marine infrastructure. Reinforced concrete became a preferred material for oil platforms, floating storage units, and massive tankers. One example, a concrete tanker built in the 1970s, remains in operation in the Pacific region to this day. In various countries, remnants of these ships can still be found today. Old barges embedded in riverbanks, preserved hulls displayed at ports, and forgotten vessels slowly becoming part of the landscape. These serve as historical reminders of an unusual but practical chapter in maritime innovation. Modern research has outlined specific use cases where concrete vessels are still economically viable, particularly for dockside infrastructure, stationary barges, and support platforms. Compared to metal ships, concrete vessels require less maintenance, don't rust, and can be produced relatively quickly and affordably. However, for ships that need to operate at high speeds or in confined waterways, reinforced concrete presents challenges. Its higher mass reduces fuel efficiency, and the resulting hull designs require more space and structural reinforcement. This makes concrete impractical for dynamic navigation or use in canals and narrow ports. Still, concrete ships remain a testament to human ingenuity. Born out of necessity, they offered a functional solution during times of crisis. And with the advent of new technologies like 3D concrete printing, already used to build houses, the concept may yet experience a renaissance in modern shipbuilding.